A single pallet of perishable fruit sits on a clean concrete floor. The cooling unit nearby is silent, and the boxes are beginning to soften. This small delay should not be a crisis. Modern logistics aims to eliminate the concept of standing still. Every square foot of warehouse space is viewed as a financial drain. Inventory is now debt that must be moved. Buildings that once held months of supply are now empty transfer shells. The goal is to keep products on trucks rather than on shelves. Speed replaces the safety of a stockpile. This is called lean distribution. It is a system designed to be perfectly efficient in a world where nothing goes wrong. Every link depends on the link before it. When a truck is delayed by 5 minutes, the dock remains empty. The workers at the next station have nothing to process. The rhythm begins to break in small increments. Without extra inventory, there is no margin for error. The system treats a traffic jam as a structural failure. Efficiency has removed the shock absorbers from the supply chain. In the past, companies kept warehouses full to protect against uncertainty. Today, uncertainty is managed by software and precise timing. The warehouse has become a high-speed pipe. Removing the extra crates makes the floor plan look clean and profitable. The efficiency of the facility is actually its greatest weakness. The system is too rigid to bend. This is the primary dock. It handles thousands of movements every day without error. It looks perfect because it has no memory of what it is missing. A worker stands by a terminal and waits for a notification. They do not know why the screen is blank. They only know that the system is not providing work. Buffers are the space between actions that absorb chaos. When you remove the space, you couple every event together. A local issue becomes a global one instantly. Every machine in this facility is tuned for maximum throughput. There is no time allotted for maintenance or observation. The system is consuming its own future stability. Success is measured by how little is left over at the end of the day. A clean shelf is a sign of a profitable cycle. It is also a sign of zero resilience. Supply chains are built on the assumption of continuous flow. When the flow stops, the system has no way to restart itself. It waits for the next command that never arrives. A single sensor light turns from green to orange. This is a quiet signal that a threshold has been reached. The system is now operating beyond its intended capacity. Just-in-time delivery requires perfect data and perfect weather. Neither of these things exist in the physical world. The logic of the spreadsheet ignores the friction of reality. The loading dock is silent and waiting. The floor markings are starting to fade from constant scrubbing. There are no boxes here to absorb the impact of a delay. Every company in the network adopts the same lean model to remain competitive. This creates a synchronized fragility across the entire economy. Everyone is optimized for the same failure. Storage is considered waste because it does not add immediate value. By removing the waste, the system also removes its own immunity. It becomes hypersensitive to time. A clock on the wall increments digitally without a sound. In a lean system, every second has a specific financial weight. The pressure is invisible, but absolute. A mechanical sorter stops moving because the bin at the end is full. This small localized halt will reach the main hub in minutes. The blockage is now part of the flow. This pattern appears in many systems. When you optimize for a single metric, you lose the ability to handle anything else. The system is perfect but brittle. Redundancy is often seen as a failure of planning. In reality, redundancy is the only thing that allows a system to survive the unexpected. Efficiency and survival are opposites. Every successful delivery reinforces the belief that buffers are unnecessary. This is the trap of a high-performance environment. Success builds a foundation of hidden risk. The loading dock is clean and the lights are on. It functions exactly as intended today. Tomorrow, a single missing truck will cause the entire facility to stop. Demand is now satisfied in hours rather than weeks. This speed has fundamentally changed how we perceive availability. We expect the system to be faster than geography. Geography is a cost that lean systems try to ignore. By treating global distances as instantaneous, the system becomes vulnerable to physical borders. Borders are the ultimate buffers. An empty shipping container sits in a yard. It is a physical manifestation of a missed connection. The system has no use for an empty box. A computer terminal displays a scrolling list of errors. The software is designed to manage flow, not to diagnose a systemic collapse. It simply records the failure. When every link is lean, there is no place for the system to store its mistakes. The mistakes must stay in motion until they cause a total halt. Speed propagates error. We have created a world where the shelves are always full until the moment they are completely empty. There is no middle ground in a synchronized system. This logic doesn't stop at warehouses. It applies to hospitals, power grids, and digital networks. We are removing the slack from every system we inhabit. The loading dock remains spotless. The floor is so clean it reflects the empty ceiling. The efficiency of the space is its only remaining feature. A single error in a database can hold up 1,000 physical objects. The virtual world is now the gatekeeper for the physical one. This is a total dependency. These patterns repeat across many systems over time. You can observe more of these structures by subscribing. The logic of efficiency always carries a hidden price. The price of efficiency is a lack of alternatives. When the primary path is blocked, there is no second option. The system has sacrificed its agility for its speed. A pallet jack is left in the middle of a hallway. It is a minor obstacle that shouldn't matter. In a tightly coupled system, it is a catastrophic disruption. A single drop of oil falls from an overhead rail. The machine continues to run, but the friction is increasing. The system is unaware that it is slowly breaking. Optimization looks like progress until the first major disruption occurs. Then we realize that we have been trading safety for small gains in speed. This is a bad trade. Every efficient system is a fragile system. We have spent decades removing the walls that would have stopped a fire. Now, the fire can spread everywhere at once. The loading dock is a ghost of its former function. It is a space designed for a world that never stops, yet it is currently standing still. We are now dependent on a global infrastructure that we can no longer see. It exists in the background, working perfectly until it doesn't. We have forgotten how to wait. Waiting is the natural defense against systemic failure. By eliminating waiting, we have made every failure a crisis. The system has no way to slow down safely. The logic of this system is to keep moving at all costs. This is why we see trucks on the road even when they have nothing to carry. Motion is the only signal. A small fire alarm begins to flash. There is no smoke, only the signal. The system responds by shutting down every door simultaneously. The isolation is complete. Every efficient system eventually encounters a limit it cannot cross. This is the moment when the spreadsheet finally fails to predict the future. The physical world asserts itself. We have built a world that is optimized for today, but completely unprepared for tomorrow. This is the ultimate hidden structural risk. Everything works until it doesn't. The system is now a closed loop that only rewards its own speed. It has no way to understand that the world outside has changed. It continues to run in the dark. The loading dock is finally at rest. The floor is spotless, and the air is still. It looks like a monument to an era of perfect efficiency. Every efficient system will eventually be replaced by one that is even more efficient. This is the nature of the game we have built. There is no end to the optimization. We have created a world that is perfect for a machine, but impossible for a human. This is the ultimate hidden structure of our modern economy. We are the buffers. Every system we build eventually becomes a system that we must live inside. We have built a world that doesn't allow for mistakes. This is our choice. The logic of the system is the only thing that remains. It is a logic that is indifferent to our needs. It simply exists, perfectly optimized and perfectly fragile. Optimization is a one-way street. Once you have removed the slack, you can never go back. You are committed to a world of perfect timing and absolute fragility. The loading dock is finally clear, and the floor is polished once again. Everything appears to be in its proper place. The system is ready to fail exactly the same way tomorrow.